Okay, I guess we are good to start. So, good afternoon, everyone, and welcome to another session of Friday presentations. And we have a very interesting speaker today, and it's an honor to have you, Ehsan, with us today. Let me introduce our speaker first, and then go to presentation. So we have Ehsan Mokhtari. Let me briefly introduce him with his short bio so that you get to know him better. Ehsan, a former student of our own CIC, has taken a notable part in Canada's tech industry since his move from Iran in 2010. He started on a PhD program in cybersecurity with Dr. Garbani and actively participated in academic and industrial initiatives in the center. In 2013, Ehsan co-founded Sentrant Security with Dr. Garbani and two other students, which was later acquired by Nielsen and S&P 500 company in 2017. Founding Sentrant Security not only underscored his business acumen, but also paved the way for him to be the first recipient of Canada's startup visa program for permanent residency. Following this success, Ehsan co-founded ChargeLab in 2020, where he has built a company of 70 employees with his co-founder. His leadership is deeply rooted in empowerment, focusing on individual strengths and diverse perspectives to foster professional growth and drive breakthroughs in market. Ehsan was recently named one of the top Canadian executives by the Globe and Mail for 2024. Ehsan's commitment to creating impactful solutions and new trained high-performing teams keeps him inspired to work with the academic and industry partners to advance Canadian startup ecosystem. An impressive short description of Ehsan, our speaker for today. Over to you, Ehsan. And he's going to talk about harnessing AI for smart EV charging management, which will be very interesting for all of us here. Over to you, Ehsan.
Perfect. Thank you very much for the introduction. I'm Ehsan Mokhtari. As mentioned, I used to be a student in CIC in the lovely city of Fredericton, spent a good 7 years there, and then, continued on my journey. And now I'm in Toronto, Ontario, and really happy to be here speaking to you, as a group. Dr. Gorbani has been always great to me. He asked me to go over the talk and also ask over my entrepreneurial journey as well. So hopefully that could be an inspiration for people who want to embark on that journey. So I divided the presentation into 3 sections. We'll go over an introduction, and then we'll dive into the smart EV charging and the role of AI in the EV charging sector. As you know, it's a growing market, and AI is going to be a significant player and application within that sector. So let me share a bit of background on the entrepreneurship journey, how I ended up here to this point. So I came here to Canada in 2010 from Iran. It's very nostalgic. This is the first email I received from University of New Brunswick that, hey, I got a PhD admission to this university. I was very excited because I wanted to be in cybersecurity. I wanted to come to Canada, and this was a dream come true at the time. And so I don't know where Linda is right now. Wherever she is, I hope she's good. She's doing well. She's been very nice to me when getting things set up. And I came to Canada right around May 2010. Everything was great. It was almost beginning of the summer. Very, very fun activities. We got set up, did a lot of work with Dr. Gorbani and the students at the CIC Center, which had a different name at the time. And then then came winter, basically in Fredericton. Winter arrived, and this is right outside of the computer science faculty. I'm sure you guys know exactly where this picture was taken. Great city, and also winter actually helped a lot for entrepreneurial journey. There is not much to do in winter in Fredericton, so you might as well do your research, do what you do best indoor, which is like really innovating and developing technology. And in Fredericton there is a really vibrant environment of startups. It just begun at the time with prominent startups like Q1 Labs at the time, and then they were later on sold to IBM. There was Radiant 6 and other startups who were quite active. They had partnership with university as well. We had weekly meetings with Q1 Labs and Sandy Bird, the CTO at the time. He's still in Fredericton, good friend of mine. And they were quite an inspiration to everybody in our center on how to make a business, how to turn research and science into a business and push to the industry, how to go through every step from research to application to forming a startup at the time. So in Fredericton, we got involved with a project. It was called the Botnet Project. It's still listed in your center, I believe. It was a very big project, a collaboration between University of New Brunswick, University of Victoria, RCMP of Canada. It was a 4-year project. I was the project manager there and also an active participant in different aspects. The project was involved around cybersecurity, identifying botnets, making sure you can detect, mitigate, and visualize the botnet behavior. For non-security audience, botnet is a connected network of viruses and malwares that they infect machines. Then they form a sophisticated network of talking to each other, communicating, and coordinating among themselves to pass command and controls to achieve a common goal. And some of those common goals are very malicious in terms of stealing information, locking down the computer, but some others are still bad, but not as malicious. And part of the Botnet project, my classmates and I, we managed to reverse engineer some of these malwares and understand their inner mechanisms. We were able to, become part of that botnet in a very non-malicious and non-threatening way. So they would talk to us, tell us what they're up to. And at that point, kind of occurred to us that this is really a good source of information. We know exactly what these infected machines are doing and how they're actually going about doing their job. And then we went one step further. And this is all happening while there is absolutely no talk of a business. So this is all within the research ecosystem. We have like our weekly meetings and discussing our findings. We realized most of these infected machines, instead of stealing data, what they do, they just click on ads. They browse a whole bunch of websites, they view an ad, they click an ad, and it took us a while to figure out the economics behind what they do, which is digital ad fraud. In 2013, that problem was an $8 billion problem in the world, and now it's upwards of a $50 billion problem in the world. It still exists. Unfortunately, the problem is growing, and it happens that if you have a website that doesn't have enough viewers, doesn't have enough traffic, you can pay these bot operators, and they would go to your website, load your website, and click on a particular ad. Therefore, you get paid because somebody clicked on an ad on your website. And the advertiser, who is not aware of this click, actually is not initiated by a human, but is rather done by a bot on an infected machine, ends up paying for it. And this, was a very good opportunity for us to turn what we have done till that point into a business. We formed Sentrant Security at the point with Dr. Gorbani and 2 other classmates, Hadi and Ali Shiravi, who were very hardworking, super smart people, great colleagues and co-founders altogether. We formed Sentrant Security in Fredericton. We were able to turn what we had discovered through research into a product that would actually tell the advertisers, hey, this particular click came from a bot, this particular click came from a human. And because we were within the botnet network and we had deterministic information, we could tell them with 100% certainty that this click was fake or real, and that was extremely valuable for them. We went ahead and actually did a few studies here and there. We published, white papers. We ran a Canada-wide study on to figure out what's the landscape of fraud in Canada, and we got a few recognition. We won the most promising startup award in Fredericton. We got featured in local and national newspapers, and also we got a lot of recognition from the media through a particular effort that we did. It was a fun story. At one point, we realized There is this Russian company that has 200 apps on Google Play Store, and they were doing digital ad fraud. When they were gaming apps and everything looked really normal, but when you close the app, it would actually go to the background and start clicking on ads. So basically leveraging your cell phone to commit ad fraud and generate money for the app owner. Most of the apps were free, so lots of installation, 50,000, 100,000, 200,000 installations. We notified Google. They took down the whole trench of apps to upwards of 200. Financial Times ran a piece on Sentrant at the time, and we got lots of recognition. And that basically led us to a successful exit at the time, because now the industry players who were interested to clean up their digital ad traffic, anybody from Facebook, from Twitter, from other people who work with advertising or work with digital measurement, were interested in that technology. This room is exactly in the center that you guys are in right now. It's the third floor facing the parking lot in the back. That was our office, and this is the day in 2017 that we eventually got acquired by Nielsen and S&P 500 company, and then we moved the technology and the team to Nielsen in 2017 and integrated that. Nielsen had called that acquisition a success. The team is still there in Nielsen. They grew from a handful, from around 10 to around 50 right now. My co-founder, Ali, is now one of the VP engineering in Nielsen. Hadi is still there. Super smart, super hardworking people. So that was the journey, coming from research all the way to entrepreneurship. Started from 2010 in research. 2 years later, we embarked on the journey to form a company. And then 4 years after that, we actually exited the company. And I wanted to share that with the students or other colleagues there in the CIC, that the journey for going towards entrepreneurship is always mixed with uncertainty. When you start with something, you don't really or necessarily finish with the same thing. We started from security threat intelligence, ended up in digital advertising fraud detection. And it's a fun journey, lots of work, but it's definitely worth it. If you guys were interested in pursuing that and had other questions, you can definitely reach out to me. I'm happy to help. It's just paying back what Dr. Gorbani and Fredericton and University of New Brunswick did for me. I worked for around 2 years in Nielsen, and after 2 years, I realized it's not really my cup of tea. It's a big, great company, nothing but good things to say about it. Fantastic people, fantastic culture, but I'm a startup guy. I needed a new challenge to solve. And at that point, it was early 2020. You remember that was the COVID time, so everything was locked down, and basically going out, participating in conferences or meeting people in person was off the table. That was a very challenging period to start a business, and I was very interested in three direction for my next chapter. And one of them was asset tokenization. The other one was artificial intelligence. And the third one was EV charging, or EV as a whole, because I'm a big fan of fighting climate change and making sure what's best for the planet. I ended up with the EV charging because I thought EV charging is going to have the most impact right now on the environment. There is an absolute big challenge for the world to solve, and we have to solve it very quickly. So that became my focal point. I looked around in the Greater Toronto area to see who is doing what, and quite by accident, I actually came across a very young and smart person who was pitching the idea of an EV charging software company to the investors. I saw that on YouTube, and 2 weeks later, we started working together as co-founders. His name is Zach Lefebvre. He's a Forbes 30 under 30, very intelligent, very hardworking, great co-founder for me so far. Now we're going to get into, and the slide after, please, EV charging, and give you a bit of a context on what is EV charging about, and then we'll get into how AI actually can solve the problem within the EV charging ecosystem. EV charging is a prerequisite for adoption of electric vehicles. Like, you can't have electric vehicles without having the infrastructure to charge your vehicle. Imagine if you have a whole bunch of cars, but you don't have any gas stations, they are pretty much useless. And that translates into range anxiety for people. That translates into billions and trillions of dollars of investment to build that infrastructure. We did not build our roads and our gas stations overnight. It took decades and decades to get to the infrastructure here, that now getting gas, the only worry you have is, where is my closest gas station? You are not worried about if I end up there, would they have enough gas? Would they have the right gas, etc.? Somebody else is running that infrastructure. Multi-billion-dollar companies are running that. And for EV charging, the journey is very similar. Now you have to build an infrastructure. And building infrastructure is very expensive. And when something's complex, it usually comes with opportunity. The landscape for EV charging is, how do you actually network EV chargers together? How do EV chargers talk to the car or talk to their cloud software? Is it a closed protocol? Is it an open protocol? Let's adopt an analogy. Imagine you are in the cell phone market, and some of you might remember early 2000s, from 2004 to 2008, when like 1 year after iPhone came out, there was this war. Who is going to win this market? Is it going to be Nokia's of the world with their own proprietary operating system and devices, or BlackBerry's of the world, or Apple then came on with like everything proprietary from hardware to software to App Store, or this new kid on the block that says, what, I'm open source, I'm called Android. Nobody took it seriously, but then started to ramping up. And over a decade, we realized, there is really two aspects to this. You either end up with closed protocols or open protocols, and each of them will have their own target audience, but generally they consolidate. You will have a very small player or a small set of players in the closed side and small set of players in the open side. In cell phone market, the dust had settled. There is iPhone and Apple on the closed side, and there is Android on the open side. And Android by far is more widespread than iPhone. The same thing is going on with EV charging. You have Tesla that has the charger. They own the car. They own the software. They own the full ecosystem. That's the closed one. And there is open protocol, which is called OCPP in EV charger. There is a authority behind it called OCA. They created this communication protocol between the charger and a backend system. We'll get into that. But then that brings the next issue here with the lack of standardization. How would that port or that connector look like? Is it going to be, I'm going to throw in a bunch of jargons here that you probably are not familiar with. Connector is going to be J1772, or is it going to be Tesla connector? And this war has been going on for the past, I would say, decade, but now the dust is settling and people are trying to find a middle ground and standardize the effort to create that infrastructure. The third point is, it's a very fragmented market. And it means your hardware, your EV charger, is probably manufactured somewhere in China or Taiwan. And then your software is probably written in Europe. Your brand exists in America, your deployment or installer probably in Canada, and then somebody else builds your app, likely in America or Canada, and now you have to make everything work together. And that is a big problem because people need to organize systems need to be interoperable, and that's not an easy task to achieve. And we'll go over the challenges. So I briefly touched upon them, but the main challenges in this emerging market is a reliable infrastructure. If you go to a gas station right now, what are the chances that you go to a pump and it just doesn't give you gas? It's pretty slim. Every time you go there, the chance that you actually are going to fill up your tank is pretty high, 99, probably 0.9%. And that's the expectation people have when they drive a car. If you go to an EV charger, it has to work. But when we look at stats outside of Tesla, which is its own category, the rest of EV chargers on the open market, their success rate is between 75% to 80%, which is quite, to be frank, embarrassing for the market. If you go to a gas station and 1 out of 4 attempts doesn't work and you have to go to another gas station, that would suck. That's really bad user experience. And that's the status quo in this market right now. And so low session success rate for a variety of reasons. The charger might be broken, authorization doesn't happen, app has a glitch, lots of issues that could go wrong. And the whole market, the whole industry has immature technology. That means your hardware is not great. There is still work to do. Your protocol is not mature. We are only working on the first generation of protocol, OCPP 1.6. The OCPP 2.0 is just coming out probably this year. People are going to move towards it. And lots of other things that is actively being worked on is like the early days of web, right? That nobody had any great browser to work with. Everybody came up with their own technology and things often didn't work. We'll see, when you have a big market and you have lots of challenges, that usually means there is opportunity there for people who want to go start a business, people who want to go and actually do proper research and build technology. The opportunity with an EV charger is, if we connect the chargers, we use smart chargers, connect them to a cloud software, we can achieve a lot for reliability. We can monitor them remotely. We could restart them remotely. We could actually be proactive about things. And for that, you need a robust software platform. That's an opportunity for somebody to come in and build. And you need to be very proactive and intentional about maintaining that EV charger network. If you know a charger having a problem, then you should probably proactively resolve it before a user goes there and gets disappointed. You can do preventative maintenance. If you realize the wire is not functioning or the screen is not functioning, you can preventatively fix it, send somebody on site, and improve that user experience as a whole. These are the opportunities that my co-founder and I, we got together and we thought we can form a business to address, to capture this opportunity. We'll see, this is ChargeLab we created. We started in 2020. So far, after 4 years, we managed to raise around $30 million to build the software required for the EV charging market. We are now one of the leading EV charging software providers in North America. We are solely focused on North America. We are not going to go cross-continent due to complexities. But as market here is big enough for us to address, and we have lots of chargers across North America connected and operating at this point. This is an introduction to give you a better understanding of how EV charging software works and how AI would plug into it. On the left-hand side, you have your hardware. These are different brands: ABB, EVBox, Siemens, any other EV charger that speaks that open protocol, which is the OCPP, as I mentioned. They speak open protocol. They connect to ChargeLab software. We are hardware agnostic. Any charger that speaks OCPP can talk to us. Same thing that you see it in other networking. If any browser speaks HTTP, it can connect to a web server. You're really trying to be agnostic there. And then what we do, we talk to the hardware, we abstract away all the complexity, and we provide a mobile app and a web app for EV drivers to talk to chargers, pay for their sessions, discover the chargers. We provide complex algorithms for fleets to manage their systems. We provide algorithms and interfaces, API for smart buildings, smart grid integration, power management, pricing, etc., etc. So that's in a nutshell what ChargeLab does. We have scaled the business so far. We are roughly around 65 people. That's actually a bit older slide. We are now around 70 people in ChargeLab. We have the biggest team is the engineering team. We build cloud software, microservices, event-driven technology there. We are pretty much across all the states and provinces in America and Canada and a few Caribbean countries. We run lots of sessions, 100,000 sessions per month, and we work with industry players such as Eaton and ABB as their preferred software platform for their chargers. This is where things, we're going to marry the whole concept into why AI matters to ChargeLab. And I know there is, at this point, there is this hype of ChatGPT and generative AI, but you guys are best positioned to know that that's not the whole AI. That's just the hype part of it. Of course, it is very valuable. But when we talk about AI, it's all about the machine learning models, all the traditional ones from a simple decision tree to neural networks to everything else. And how can they actually be applied on a new domain, especially in this case, EV charging, to make things better, to solve real life problems. The reason AI is a great fit for the EV charging application is we process vast amounts of data, and it's not just the sheer amount of data; it's the diversity of the data. Every charger is implemented differently. They speak a common protocol, but a protocol is a communication method. It doesn't tell you about the specification of a charger. We currently work with 70 different makes and models of these chargers. And each of them have their own quirks, have their own edge cases. Some chargers behave in a certain way and send us different messages. Same thing, I'm going to just refer you to different browsers. If you have a website, it might work in Chrome, not work in Firefox and some other browsers from other parts of the world. So that's the same thing. Just the fact that the protocol is the same doesn't mean the functionality is the same. And then you have the user interaction with the charger, the car interaction with the charger, the connectivity piece, right? All of them, when they combine it together, data comes from different sources, and now you have to interpret it. And AI is a really, really good tool for that problem. On top of it, when you have this amount of data and there is no standardization around it, it's very important to establish the baseline. What does good look like? And anything deviating from good would be an anomaly. And cybersecurity are very familiar with that. You have signature-based detection, you have anomaly-based detection. And here we are heavily focused on anomaly because the baseline is not really known, and we need to define the baseline to determine the anomaly detection. AI is a great fit. Predictive analytics, this is another fit for AI. We have a lot of data that can help us predict the future based on a past behavior. Let me give you an example. If a charger is in open space, and we analyze the data in the past, figure out when the weather condition changes, it's rainy out there, the success rate of a particular session drops by 40% because the moisture might get into the connector of the charger. When you connect it to the car, it will just not give you power. It's dangerous. So therefore, you can actually predict the behavior of a charger based on external or internal factors, makes it a perfect fit for AI. And also customer interactions. In this case, the GPTs will come in and generative AI. You can now translate the technical data, the results into a human understandable interactive method to allow people to chat with the system, to get information in plain English as they need it. You know, what we actually do there for AI in ChargeLab. ChargeLab has an internal project that I'm personally leading. It's called ChargeLab Spark. This is a suite of AI tools that we built and use in ChargeLab across our portfolio of products. You know, there is a lot of secret sauce and intellectual property that I can't get into it. It's being prepared to be filed as a patent. So if you guys were interested, you can reach out directly. We can get to it on a private call. But you know, there are a few components to this suite of product. OCPP is the communication protocol between an EV charger and the backend software which ChargeLab runs. This tool set is able to understand the protocol, understand the state machine, the edge cases, establish the baseline and detect anomalies based on that protocol, and then explain what goes wrong or what happened during the particular time period in plain English. It is able to detect issues in real time. It is able to identify patterns in real time. And then on top of it, it can actually digest information from different sources. Imagine if a particular charger comes from manufacturer X. They usually, you know, send a user manual, a PDF file, I don't know, 70, 100 pages, explaining every single LED on that charger. If it blinks blue, this is what it means. If it blinks purple, blinks consecutively, not consecutively, if you connect it this way, all of that intricacies that you have to go through, we actually digest that, put it in a proprietary vector database internally. And when we detect an issue, the bot is actually context aware. It understands the charger and the particular firmware version on the charger, looks at the possible solutions. So it basically formulates the problem, tries to find the solution, formulates the solution, and then communicate that to the user, to the stakeholder, which might be internal user within ChargeLab or external, an installer trying to figure out what is wrong with this charger or a site host there. So this is the sample dashboard that we use internally to proactively monitor our network. And you can see different, signals, different errors, different behaviors that this tool is picking up in real time. And we have our staff who look at this, go through different signals we receive, filter out the false positive, and actually create a data set. So whatever we label with human touch, we create a data set from it later on that is being used to train the model even better. So as we go forward, the model is going to be more intelligent, less error prone, higher, lower rate of false positive, etc. And this is, variety of components in that Spark suite. There is a Spark Chat, Spark OCPP, Spark Patrol, different components. One of them specifically that I'll dig a bit deeper here is Spark OCPP. And that means, can you actually work with a super technical protocol and train your AI model to understand that protocol, parse the logs, and then transfer it and translate the technical data into plain English, diagnose the patterns that could go wrong, and then provide a solution based on the context, based on the charger, based on the behavior of that charger, and tell you where to begin, where to look at, and that would increase your productivity when you actually try to improve the reliability of that charger. And that would be, this is a sample of an OCPP log. So this is what we get, goes back and forth. This is actually quite real for a particular charger. I just crossed the ID to not reveal any information there. But this is OCPP logs, jargon JSON file that gives you commands and controls, and the system understands it. And generally for diagnostic, currently the industry will look at these logs, would try to understand and act upon it. It's not super useful for non-technical people. We feed this log into OCPP, a Spark OCPP, and it basically gives us this result in real time. And for that particular log, the log file was around 1,000 lines back and forth for over an hour period of communicating from the charger to the backend and forward. And the AI tool will give us a diagnostic summary. It will say this charger identifies exactly what's the firmware version on it, has consistent connectivity. I highlighted the important parts, and it says that a transaction was successfully initiated. This is explaining what happened during this period. And then the charger actually delivered power from 16 kilowatt hour to 49 kilowatt hour. The amperage actually fluctuated between 21 amp to 111 amp, and the voltage was relatively constant from 430 to 446. And then in the issue analysis, it will try to identify any sort of things that could go wrong. And in this case, actually, it detected that the charger is creating new connections to us, meaning a possible stability or connectivity issue for this charger. While it did a successful session, but it doesn't mean it's actually doing very good. The charger, while doing the session, reconnected to us repeatedly, and it likely will have a connectivity issue. The good news is when the charger reconnected, it was able to honor the timestamps, meaning that it did not lose the state. And so therefore the session was successful, and the termination was actually was okay, but a potential issue might be there because there was a timeout. And in the actionable insights, this is where it actually gets a bit more creative, and it will try to tell you where to look at. It says it is recommended to investigate the stability of the charger's network connection or potential hardware issues. It detects that this rate of reconnection is likely a hardware issue. Maybe your Wi-Fi connector is not acting properly. Maybe your modem is not acting properly because we saw frequent reboots. And you have to rule out the hardware faults before doing something else and looking at your central system. Also, it detects that because of that timeout, there is we have to make sure that the system can correctly process end of transaction signals. And that would be a great area to start looking at. This is completely functional in our system. We use it on an everyday basis, and we'll be patenting the underlying technology that got us here. And our take is, as the technology matures, this could be autonomous, proactive, working across the tens of thousands of chargers that we connect and operate. and provide proactive notification to people who maintain those chargers. Send them a signal and say, well, your charger seems to be working, but it is experiencing frequent reconnection. Go check out your router, maybe do a restart, etc., etc. But these are all like scratching the surface, of course. We just started to integrate AI over the past 6 months into the platform, but there are concepts that we are working on, and these are, in our opinion, future works that would be extremely valuable to this industry, and we have a lot of problems to solve. Just to put that in perspective, we currently have around 3 million chargers connected in North America, and in less than a decade, that number should be around 28 million, a tenfold increase. So you could see the opportunity here and the things that we need to do to make sure all the 30 million chargers actually work well and properly. We are building a charger network operations center, or a CNOC, within ChargeLab that will leverage AI and signal generation and anomaly detection to take care of the overall health of the whole system. A big initiative is predictive maintenance. Some of these chargers do report their temperature, their connectivity, the health of their internal components. Can you actually build a model to tell what a component is going to fail before actually it fails? There is a huge cybersecurity landscape here. At ChargeLab, we take cybersecurity very seriously. I'm a bit biased towards it because I do come from cybersecurity myself. These are all connected devices, right? And your network is as strong as your weakest link. So if you are a business and you have an EV charger in your parking lot connected to your Wi-Fi network, and somebody hacks into that EV charger, your whole network is compromised. We have a security team within ChargeLab that takes care of our security, and they're dedicated to it. We just got our SOC 2 Type 2 compliance, and we are going to be embarking on FedRAMP, which is a lot more intense security program run by the government of the United States. We are doing some research on cybersecurity, especially on detection engines, on if a charger is malbehaving, if it's DDoSing other networks, if it's DDoSing its own network, etc., etc. Next slide will be listing a bit more future works for the application of AI. In case you guys want to move to that direction, there is a lot of work to be done on power management and load management. That's a big area of work because the grid, simply the power grid, is not equipped to allow for charging all the EVs in the market. A simple, like if you're driving a Tesla, you know this, the battery is huge. And a Tesla could actually store enough power in its battery to provide power back to your home for 3 days without compromise. So charging that car in every home, imagine everybody has an EV, the grid is not going to be able to sustain that. It's not built for it. That's trillions of dollars of investment to upgrade the grid. Or you could do the other things. You could actually be smart about it and do power management. If you have 10 different cars charging at the same time, try to apply an algorithm. Maybe you do give them equal charge at the lower rate. Maybe you do round robin. Maybe you do weighted average. So there are lots of ways to actually read signals from the grid and manage the power consumption. And then next step, probably over the next 5 years, will be to enable the vehicles to provide power back to home and back to grid. So when you are at the peak time, instead of drawing from the grid to do your cooking, you can draw power from your car and do your cooking. And very ambitiously, I think over the next 10 years, we'll see virtual power plants. If you group 1,000 cars together, that's a huge amount of energy. That's probably more than a regular power plant when they provide power to the grid. So instead of having backup power plants, you can incentivize people to sell their electricity back to the grid through this virtualization. And of course, pricing optimization, how do you price your charging sessions? And these things are super interesting directions that we could leverage AI to deal with. And I think with that, I would, next slide, I would end the presentation, and hopefully there is enough time for any question and answers. And again, thank you for the time. This was super exciting.
Thank you very much, Ehsan. Thank you for that nice presentation and your journey as a researcher as well as an entrepreneur. I think you might have a lot of questions for you. Any questions? Yeah.
Okay, in the Spark results, Spark analysis results, do you use a role-based approach or a model-based approach to get the analysis result?
Yeah, great question. So we actually do model-based approach to establish the baseline. So we actually define schemas for that protocol and then build different state machines based on what we see in the wild. It's not like you can't really build it just based on the protocol. What we do is we actually create controlled environment for chargers that we know they're behaving well, capture that traffic. Based on that, we build a model, and then that model becomes the baseline for that particular charger. And according to that, we can detect anomalies.
On top of it, when you say it is a model based on the schemas, is it like you have defined thresholds or neural network kind of thing? Just curious.
Yeah, so there are defined thresholds, but those are very specific to every charger make and model and the firmware versions, and we tweak them. Some of them manual, some of them automatic, and the automation happens when we see a raise in the false positive rate of our detection. Then we match that, the part that I left out here, with the number of customer support tickets we get, because that's a great labeling of the data set. We know if something went wrong, if somebody calls us, right? We marry them together, and that will actually allow us to sustain the right and determine the right threshold for defining a signal.
Okay, thank you. The one last thing, it is out of the AI, it is about the startup or business side. When you say when you move from the previous company to build a new startup, the context is like a B2B type of business, right? So how did you first initiate the groundwork and first get connected with the first client? Thanks.
Yeah, so you mean from a business side or from like figuring out the product side?
Or business side, yeah.
Yeah, the business side is you always start with the sales. So you, instead of you build like a very super MVP, like a minimum viable product. And we did that. We started with an open source project. We took it, we tweaked it, and gave us a presentable product in really quick time. And then you just go talk to people, and there are many ways to find those lists, go to conferences. At that point we couldn't because of the COVID. So what happened is you actually go to your network, ask for introductions, and you just go to so many people and pitch your ideas. And this is how you learn if you're onto something or you need to actually refine it. And eventually somebody will give you a break. And those people are the ones that generally, in my experience, have two features. One is they do have a problem that they are losing sleep over it. And second, they empathize with you. They probably have been there before, so they want to help you. And if you can find those two features in a potential client proactively, they could be the people who actually work with you along the journey. And we have people that we started working with them in the beginning. They are still a customer. We try to take a good care of them, even though now we have much bigger customer, but they still get the front row seat.
Thank you.
Okay. Thank you, guys. Take care.